Okay, here's another situation. This comes from, I think it's example 4 in your book. They give you a situation where somebody's moving, and they're going to figure out the cost of moving. Um, so pay attention to the details here. Jay is moving from an apartment in Miami to one in Orlando. If Jay moves on a weekday, he will need more movers time to pack, load, unload, and unpack because his friends will not be able to help him. If he moves on a weekend, he can get his friends to help, cutting down on the number of hours he will need to hire the movers. So there's a company named MoveOut, um, and they're given the following estimates. So if they do a weekday move, it's going to take 6 hours of loading and unloading, 5 hours of packing and unpacking, and that cost would be $720. Whereas if we had a weekend move, there'll be only that much loading and unloading, that much packing and unpacking, and a total cost of $400. Um, so they do charge um, a set hourly moving team rate for loading and unloading, and a different set hourly rate for the packing and unpacking. So that's going to be really important as well. Um, I'm going to confuse you with my highlighting here, so I'm going to actually go back and erase that and that and that. We're going to do this a little bit differently. All right. Oh, so I'll get rid of all that. Okay, so you can kind of see there's two different things going on here. Um, we have loading and unloading in both scenarios. We have packing and unpacking in both scenarios. And then, of course, you have a total cost. We're going to develop here what's called a system of equations. Now, I know you've done this before because you've all had Algebra 1. Um, and so basically, each of the different colors I use there for highlighting is representing a different variable. What we want to do is say up front what our variables represent. So in this case, we'll say x equals, we'll just call it loading, even though it represents loading and unloading. And then we have y would represent the packing and unpacking. All right. So we're actually going to have two different equations here. The first one is going to be 6 hours of loading and unloading plus 5 hours of um, packing and unpacking equals $720. And in the second situation, we have 4 hours of loading and unloading and 2 hours of packing and unpacking, and that is a total of $400. And now we're going to solve a system of equations. I don't know if you guys remember this, but there's this fancy little trick called elimination that you've been taught. What elimination is, basically you're going to multiply both equations by something in order to get two of their variables to line up or to match up so that you can solve for the other variable. What I mean by that is this. I noticed that there's a 5 and a 2 in front of the y's in the separate equations. If I can get those two to be the same exact number except opposites, then I can do something called elimination. So if I multiply this equation by 2, that will give me 12x plus 10y equals 1440. And then if I multiply this equation by negative 5, I'm going to get negative 20x minus 10y equals negative 2000. And if I add those equations together, I get negative 8x equals, that's going to be negative 560. Because the 10y and the negative 10y become 0 when you add those together. So then if I divide both sides by negative 8, I'm going to find that x is 70. That looks like 76. It's supposed to be 70. It's a little bit better. All right, so x equals 70 means that they're charging $70 per hour for the loading and unloading portion. So now we're going to figure out the packing portion. And to do that, we just take this information that we got down here for x and put it back up into one of the original equations for x and solve for y. So that will look like this. Let me just do this for a second. All right, so we're going to do 6 times 70 plus 5y equals 720. All right, 6 times 70 is 420 plus 5y equals 720. Subtract 420 and you get 300. And you will find that y in this case is 60. So it costs $70 for the loading and unloading and $60 an hour for the packing and unpacking. We're done with that example. Now, there's another way to do this. You can graph these two equations. They're linear. You get y by itself and graph them by hand. Or we can get out our handy dandy Desmos and we do that. I'm going to hide some of this stuff here. Get rid of all that. It's working a little slow, sorry. There we go. On example 4, you'll see that I've already typed in the equations, and they are, they're just sitting right there. If I turn them on, you'll see that they show up. And if I zoom in, if I zoom in on that, gotta give it time. It's taking a lot longer than it should. I'm gonna save that. May have to come back in. Sorry for that. Okay, we're going to get out of Desmos and get back in. It's a much longer video, sorry about that. Alright, I'm going to open 8.1 samples. Let's open that up. Oh good, it's ready to go. Alright, so I'm going to put that up back on projector mode so you can see it. And we're going to do this, and we're going to do this. So you can see, all right, so here's the cool thing. These two lines are intersecting. The place where they intersect, that's the place where their x's and y's are the same. Which means I should be able to tap on it, and there we go. I got 70 for x and 60 for y, and all I had to do was write the equations in Desmos and graph it. And then select the point. Again, you have to know what the 70 represents and what the 60 represents, so it's still important to set up your equations and know your variables. But it's a little bit of a shortcut.